Welcome to Study Loop.
Once again, we have a new problem. This time, it's a sledge that's has two people inside. So we have uh, Jonathan, and then we also have his friend Jen. So the mass the weight of Jonathan, the weight of Jonathan is given us is equivalent to 800 newtons. And so we can change that right away to the mass of Jonathan, which is 800 newtons over 9.8 meters per second squared. And if you do the numbers for that problem, you get 800 divided by 9.8. That's 81.63 kilograms. And then also we have Jane. So the weight of Jane is given as um, 600 newtons. And we can change that to the mass of Jane, which happens to be 600 newtons over 9.8 meters per second squared. And that's going to give us, if we do the number 600 divided by 9.8, that's equivalent to 61.22 kilograms. So those are their masses. And also the sledge itself, the mass of the sledge, or rather the weight of the sledge, happens to be 1,000 newtons. And so we can get the mass of the sledge by taking 1,000 newtons divided by 9.8 meters per second squared. And that's going to give us a mass of, so this is 1,000 divided by 9.8, that's 102.04 kilograms. Also, we're told that the sledge is riding it's at rest. So initially the sledge is at rest, and then what happens is that they see a poisonous spider, and Jonathan, who happens to be um, uh, on the left, so Jonathan jumps towards the left with a velocity of 5 meters per second. So this is Jonathan jumping towards the left uh, with a velocity of 5 meters per second, and the angle is 30 degrees. And then we have on the other side, we have Joanne, who jumps to the right uh, with a velocity of, well, this is Jonathan. So this is, uh, yes, Joanne jumps to the right, or rather, not Joanne, Jane jumps to the right with a velocity of 7.00 meters per second at an angle of 36 point, so this angle 36.9 degrees. So this is the information that we're given, and we want to find the uh, horizontal velocity of the sleigh in terms of magnitude and direction uh, after they jump. So what's going to happen once they jump, and we're going to do that on the next page. So we're saying we have all this information that we're given. So first of all, we think of Jonathan. uh, he's going that way, and so he has a velocity of Jonathan happens to be If you go back, it was 5 meters per second, 5 meters per second. And this velocity can be resolved into Jonathan's x component and Jonathan's y component. But in the x component, he's going in the negative direction. So this is negative, and therefore the velocity of Jonathan in the x is given us negative regular velocity of Jonathan times cosine of theta. This theta is 30 degrees. So, well, actually it's 30 degrees to the horizontal. So we have to remember that. So going back on this one, we should change these numbers a little bit. So this one is 30 degrees to the horizontal, and this one is 39 degrees also to the horizontal. So we have to be careful with those angles. So this one happens to be this is 30 degrees, and this is 36.9 degrees. So going back, we get the velocity is 5.00 meters per second, and then we want to multiply that by cosine of 30, and so this gives us negative 4.33 meters per second. And then we do the same thing for Joanne. We say going that way towards the right, this angle is 36.9 degrees. So and the Joanne's velocity, or Jane's velocity, I don't know why I'm saying Joanne all the time. Jane's velocity happens to be 7.00 meters per second. So her horizontal velocity, this is Jane's velocity in the x, and this is Jane's velocity in the y. In the x, Jane's velocity will be her regular velocity times cosine of theta. So this is positive 7.00 meters per second times cosine of 36.9 degrees, and this is going to give us 5.60 meters per second. So these are the velocities in the x. So in the next page, we'll use the law of conservation of momentum. Okay, the law of conservation of momentum. Remember, once they jump off, Jonathan has a momentum, the sledge has a momentum, and also Jane has a momentum. So this is what happens once they jump off. Moving that way, moving that way. So we want to find what direction will the sledge be moving. So in this case, we say mass of Jonathan times velocity of Jonathan in the x plus mass of the sledge times velocity of the sledge. We don't know what the velocity of the sledge is, times mass of Jane and velocity of Jane in the x. That's going to be 0 in terms of momentum because of conservation. So solving, we end up with ms vs equals to, we move these two to the right. Both of these go to the right. So we have mass of Jonathan, velocity of Jonathan in the x becomes negative, minus mass of Jane, velocity of Jane in the x also becomes negative. Then we have to divide by the mass of the sledge on both sides. And so the velocity of the sledge becomes negative. We have to go back and get the mass of Jonathan, 81.63 kilograms, times velocity of Jonathan in the x, which is negative 4.33 meters per second. And then minus Jane, 61.22 kilograms. And velocity of Jane in the x you can see it happens to be 5.60 meters per second. Um, Divided by the weight or the mass of the sledge, which happens to be this one right here, 102.04. And we had to do the conversions. You could have waited up until the end to do the conversions. So then we finally find out that the velocity of the sledge is um, positive. It's going to be positive. So 0.105 meters per second to the right. So that's what you have in that problem. Hope you enjoyed it. Feel free to send any questions or comments and make sure you have a wonderful day. Okay, thanks. Bye.